Hello and welcome guys to another video on the topic of forces. Now as you already know, today we are going to talk about the next category of forces, which is nothing but the non-contact forces. Now as their name itself suggests, non-contact forces are born out of interactions when two bodies are not touching each other. So these forces are born out of interactions where there is no contact. Now, the classic example of a non-contact force would be the magnetic force. We talked about magnetic forces in the last video as well, but in case you missed it, let me remind you that when two magnets are brought close to each other, they either attract or repel based on which poles are facing. Now, both the attractive and the repulsive forces together are called the magnetic forces, and they are non-contact in nature. For instance, you can see here that the like poles of the two magnets are facing each other. The result is a repulsion between the two. So each time we move a magnet, the other moves automatically without any physical contact due to the non-contact magnetic force acting on it. Same is the case with attraction as well. So when the unlike poles are brought close to each other, the magnets attract. Here also, we have a non-contact force acting. Now I must hold you down here. In case of attraction, you saw that the two magnets ultimately came in contact with each other. So do you think there was any contact force involved in case of attraction? No. Don't confuse yourself into thinking that. The attractive force which ultimately pulled the second magnet towards the first was still the non-contact magnetic force. There was no contact force involved. In fact, the contact force came into play only when the magnets hit each other. Now, in a similar manner, when a magnet attracts objects made out of iron, cobalt or nickel, it still applies a magnetic force to pull those objects towards itself. Now, once again, you can see that the magnetic force acting over here is non-contact in nature. Great. Let's move on to the next non-contact force. Any guesses for what it could be? How about gravity? Yes, gravity or the gravitational force is another example of a non-contact force. Now, gravitational force by definition is an attractive force that acts between any two objects in the universe. And when I say any, I literally mean any two objects with mass. Yes, this includes you and the computer on which you are watching this video as well. Now I know what you are thinking. You are thinking that if that's the case, then why is my computer not hurtling towards me and hitting my face? Well, although it's an obvious question, but it's still a good question. So let me explain. You see, the force of gravity depends on two main things. First is the mass of the objects involved, and second is the separation or the distance between the objects. Now, the heavier objects will apply more gravitational force compared to the lighter objects. Similarly, objects that are close by will have more gravitational attraction compared to the objects that are far away. Now, for the gravitational force to be anywhere significant, we need really massive objects. Something on the scales of the celestial bodies, like the Earth, the Moon, the Sun, and the planets. Anything less massive than these will have very little gravitational force. For instance, we all know that Earth's gravitational pull is significant. The moment we release our grip on any object that we are holding, it races down towards the Earth's surface because of the Earth's gravitational pull. Now, this is the reason why anything and everything on Earth falls downwards and doesn't go up or simply float right where it was. So, you're clear about the Earth's gravity. But what about Moon's gravity? Well, I'm sure you may have seen the videos of astronauts jumping on the surface of the moon. Now, if you notice carefully, an astronaut is able to jump to a significantly higher height on the moon as compared to what they would have jumped on Earth. Now, this happens because Moon's gravitational pull is significantly less compared to the Earth's gravitational pull. And that's because the Moon's mass is significantly less compared to the mass of the Earth. But still, the Moon is massive enough to have some significant gravitational effect on the objects on its surface. So, technically speaking, yes, you and your computer are definitely attracting each other via gravitational forces because both of you have masses. However, that force is very, very small, and therefore you are not exactly moving towards each other because the other forces, like the force of friction, is able to counter that little gravity very, very easily. However, if you go into the deep space, away from any other influence of force, you will see that your computer will indeed come towards you, but very, 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 very slowly. Brother, that was a long, long time. Now, you may have a million years to spare, but I don't. So let me go ahead with the next fact in the series of awesomeness about gravity. And that is that the gravitational force of Earth that we were just talking about, which pulls apples, oranges, humans, buildings, everything towards its surface, is the same force that pulls the moon towards its surface. Yes, I bet you did not know that. So it's true. The Earth's gravity is the reason why moon revolves around Earth in a fixed orbit. To understand it better, imagine Earth's gravitational force as a rope that is constantly pulling the moon towards itself. And moon is like a puppy which wants to run away from Earth. So moon wants to run away from the Earth, but Earth won't let it. That's why moon goes around the Earth in a fixed orbit. In the same fashion, Earth goes around the Sun in a fixed orbit because of Sun's gravitational pull on Earth. So let's move on to the next force in the category of non-contact forces. And this is nothing but the electrostatic forces. Now, some of you may know that electrostatic force is the force that acts between any two charged bodies. Now, we talked about charges and their types in the previous standards, but in case you've forgotten them, let me quickly take it up and remind you what they are. So, just like the two poles of a magnet, we have two types of charges as well. The first is the positive charge and the second is the negative charge. Now, the concept here is that like charges repel each other and unlike charges attract. So, two positive charges repel each other and so do the two negative charges. But a positive and a negative charge attract each other. So, the electrostatic force is nothing but this attractive and the repulsive force between the charges. Now, the easiest way to charge a body is by the action of rubbing. So, take a plastic ruler and rub it over your head for some time. Now, this action of rubbing transfers some amount of charge from your hair to the plastic ruler. Now, if you bring this ruler close to some bits of paper, you will see that the bits of paper get magically attracted to the ruler, although there is no contact between them. So, what is this non-contact force acting between the bits of paper and the charged ruler? Well, it's nothing but the electrostatic force. Interestingly, if you take the same charged ruler and place it near a thin stream of water coming from a tap, you will see that the ruler ends up attracting that as well. Pretty cool. So from here we can say that an electrostatic force is acting between the charged ruler and the stream of water. And once again you can see that the force is non-contact in nature. So guys, that's it for today. I hope you had a fun-filled session on the topic of non-contact forces. In the next video, we'll see how forces end up creating deformations in the shape of different objects. Till then, let's summarize what we learned so far. Non-contact forces, as their name suggests, are born out of interactions that do not involve any contact between the two bodies. Examples of non-contact forces are magnetic forces, gravitational forces, and electrostatic forces. The force of attraction between the unlike poles of two magnets and the force of repulsion between the like poles of two magnets are together called the magnetic force. Apart from that, the force with which a magnet attracts objects made out of iron, nickel, and cobalt is also called the magnetic force. Gravity, or the gravitational force, is an attractive force that acts between any two bodies that have mass in the universe. The strength of gravitational force depends on two things. First is the masses of the objects involved, and the second is the separation between the objects. Now, massive objects like the sun, the moon, the earth, and the planets have significant gravitational force. However, the objects that we see in our daily lives are not heavy enough to have any significant gravitational force at all. Electrostatic force is a non-contact force that acts between any two charged bodies. The easiest way to charge a body is by the action of rubbing.